What is up, guys? Welcome back to a new video. Today we're going to be solving this. We want to determine the set of all z's in the complex number plane that satisfies the following equations or inequalities. Now, to do this is quite easy. So let's begin with the first example. First one. So we have this, and we want to find the sets the set of set, right, in the complex plane. How do we do that? Well, we simply start first by saying, okay, we know that set is equal to this, right? So we can simply write that into our equation, a plus bi plus 1, like so, right? Now, what does this denote? This denotes basically that we are going to do simply this, right? Oh, no, before we do that, I probably forgot. We have to just group up our real parts and our imaginary parts. So that means we take our real parts, right? And then our imaginary part. So as you can see, we have our real part, imaginary part. Now what we're going to do is we know that whenever we have, this is just another example, whenever we have a plus bi, this is simply going to be a squared plus b squared, right? That's simply it. So in this case, we're going to do the same thing. Square root of a plus 1 squared plus b squared 2. As you can see, we cannot really, we want to get rid of this square root. So we're going to square each side. That means we have plus b squared is going to be equal to 4. And now we're simply going to write now a squared plus 2a, I think, plus 1 plus b squared. It's going to be equal to 4, right? Simply, we can keep on working this, and we can simply say that we're going to have a squared plus 2a, plus 2a minus 3 plus b squared, right? Or simply a squared plus 2a plus b squared minus 3 is equal to 0. So that's basically it. Yeah. That's basically the set that we want, right? That's a set that we want, such that we get 0. So the equation of this is basically, yeah, I'm sorry, I just got totally confused there. But this function, basically what it's telling us, it's that if we go back to how this looks, yeah, to how this works, right? We go back to this one, we can simply see that this is basically going to make a circle. Why? Well, if we remember back, the center form of a circle, normally we have a plus or minus h squared, right? And then plus b minus k squared is equal to r squared. In this case, if you can see, a plus 1 squared plus b squared is basically the same thing. We don't have a k in this case, and our h is negative, so it becomes positive. And that's basically it. This means that we create a circle, right? There's a circle centered at -1, -1, and 0. What that entails is that we have a graph here, right? Oopsie. Let me put a graph here. We're going to have a circle here that grows like so, right? And that's pretty much it. And it will have a radius of 2. Why? Because of this little guy. We have, in this case, it's not 4, sorry, it's just 2. And the radius is 2, yeah? Meaning we'll have just 2 units of radius. So yeah, that's pretty much it. If you guys want to do an exercise, let's just try to do, I don't know, inequality in this case. Let's try to do 2, right? 2. 2 tells us set minus 1. Yeah. And set plus 1. Great. So we do the same thing. A plus bi minus 1, a plus bi plus 1. And then we are going to have, yeah, this thing and this thing, right? Basically, this is going to be a minus 1 squared plus b squared, a plus 1 squared plus b squared. In this case, it's going to be minus, actually, minus b squared. Is it? No, just plus. Plus, yeah. In this case, we would have 2 square roots as well, but we just square the both sides, so we remove them. It's as easy as that. So now that we have this, we can simply just put common terms. We have to first solve this. A squared minus 2a, minus 2a plus 1 plus b squared. This will be a squared plus 2a plus 1 plus b squared. We move the common terms. These ones are the same, so they cancel themselves out. These ones are the same, so they cancel themselves out. These ones are the same, so they cancel themselves out. And minus and plus 2a, they do go with each other, so it's going to be, so to speak, we can go just simply 0 for a. So basically, our set has to be within complex numbers such that 0 and 4a is bigger, right? So in this case, what will this entail? Let's check it out. Okay, so coming back to it, basically, we forgot one little step here. Sorry about that, guys. Basically, 4 goes to the other side, so we get basically that. Yeah. So we have sit in complex numbers such that a is lower than 0. What this entails in a graph is we know that a is the real numbers, right? This one is the real numbers, imaginary numbers. So this is basically b, is a. And basically, what this entails is we cannot get any x further than this. So we can only get x's on the left side, meaning that our graph will look something like this. The red part is what we want. So it will look something like that. Why? Because a cannot be bigger than 0. It can be only lower than 0. Hence, it goes to the negative parts. So yeah, guys, hopefully this helped you out to understand the actual things and how these guys work. You can also do more of these. And remember, if you're confused, you can always use ChatGPT or Wolfram Alpha. Right now, I kind of forgot how to do them. That's why I paused the video a bit. And I just Googled it. I just ChatGPT'd it, basically. And he told me step by step how to do it. So if you guys have any like looking or like doubts or something, you can always base yourself on ChatGPT. So yeah, thanks for watching, and I'll see you in the next video.